Hello, welcome to S&J Engines. I'm Jeff Johnson. This video, as part of the engine manufacturing process, is about crank grinding. Now, the crank grinding process is once again very critical. The largest clearance we have in any engine we remanufacture are the pistons, and they are 0.02 of an inch. The crank, which supports the rod bearings and the main bearings, are down to 1.5. We'd like 1.5 thousandths clearance for the oil between the bearing and the crankshaft. We use the Burco crank grinders. We have 2 Burco crank grinders. And by the way, if you don't have a Burco, you don't have a crank grinder. The Burco, we have one Burco for grinding the connecting rods, and then we have another one for grinding the mains. And then after we're done grinding, we have a polisher. Now, what's important about crank grinding? Well, first off, as you can see, the crank grinder supports the crank on one end, where the harmonic balancer is, on the other end where the flywheel is. And that has to be 100% true. You can't grind it crooked. You can't have the front end higher than the back end or vice versa. They have to be set up perfectly. And a lot of people use what we call a fixed head. We don't do that because on a fixed head, that crank can be bent, which we check to make sure that it isn't before we grind it, but it could be bent 0.5 thousandths. So what happens is you will grind that crank high to low, from front to back, 0.5 thousandths off. We use what we call floating heads. Both the front and the back chucks, which hold the crank, are movable. And we will put dial indicators on each one, the front and the back, and then we will dial that crank in to make sure it's perfectly straight. Then we'll grind the connecting rods. And once the connecting rods are ground, we go to the next crank grinder. The same thing is done again when we grind the mains to make sure that the mains are perfectly in a line. And we're talking under 0.1 thousandths of an inch. So we grind the rods, we'll grind the mains, and then of course this is a rough cut. We've ground it down to within 1/1000th of where it's supposed to be. Let's say we're grinding at 10 under. From there it has to go to crankshaft polisher. The crankshaft polisher that we use is a fixed fixture, and it uses a rigid surface to polish the crank. The old polishers that we used a flexible belt, and it would move up and down with the crank as the crank turned. And what we discovered was, as the connecting rod as the crank came up, the polisher would take more off than when it went down. So the polisher would follow the crank up and down, taking more off as it came up, taking less off as it went down. Not a good thing, because once again, we're talking 0.5 thousandths. If you take 0.5 thousandths of an inch off, instead of having 1.5 thousandths clearance, now you have 2 thousandths clearance. Only that 2 thousandths clearance ended up being on one side. Not a good deal. So what we found is this polisher with the rigid, the polishing belt is held on a rigid surface, and we can keep constant pressure going up and down and polish that crank, by the way, very, very smooth down to 8 RA. So we know that we have a good flat surface for the bearing to ride on. And the other important thing with this new polisher is that it will polish the thrust bearing surface. The thrust bearing is used only when the engine shifts gears, whether it's an automatic or standard makes no difference. But when the automatic or the standard shifts gears, you shove in the clutch, you shove that crankshaft forward towards the radiator. When the automatic transmission shifts, it builds up hydraulic pressure. It does the same thing. It shoves that crankshaft forward towards the transmission. You have to have a really smooth finish on the crankshaft thrust surface, or you will knock that thrust surface out really fast. This polisher will polish the thrust surface on the crank to the same 8 RA as it does on the bearing surface.
For more webisodes, check us out online at www.snjengines.com.